Have you ever wondered how engineers extract information from an injection well? How they behave at given pressure? Or how much fluid is able to be injected back in the future? Back to the previous video, it has already explained that after history matching, injection mass flow rate should be normalized at the constant wellhead pressure value. But how is normalization? Reservoir parameters that have been obtained from history matching are used to make predictions based on constant wellhead pressure value. These data will be the references of the decline curve analysis. This technique was widely used in the oil and gas industry, and then adapted into geothermal because of the same principle between geothermal well and oil well. Decline curve analysis involves trend fitting from normalization data to a mathematical curve, such as exponential, harmonic and hyperbolic curves. Then, we know how good the well's performance is and to get a clear estimation about what will happen in the future. The exponential regression is often used in the injection model since it gives a more conservative calculation. Exponential model assumes a flow decreases by constant fraction or percentage per year. And here is the detail about the exponential regression, where m is injection mass flow rate in kilogram per second, m0 is initial injection mass flow rate, d is the decline rate, t is the cumulative time since the start of injection time in day. We will estimate the value of m0 and d so that the error between this equation and the normalized data are minimum. After that, we can make a prediction of the future mass flow rate injection. Here are the few steps to obtain both m0 and d value. First, we have to initialize lane function in both sides. Based on the lane properties, we can separate the right side into lane m0 plus lane e dt, and then shift the power of e to the front of lane e. Since the lane e is equal to 1, therefore it can be neglected. Now we have lane m equal to lane m0 plus dt. Then we can restate this equation into this form. Now as you can see that this equation is similar to simple linear regression equation, therefore we can solve this equation with linear regression formula below. By the time we are done calculated the value of a0 and d, we can obtain the value of m0 from this equation. Decline rate is defined as the coefficient of t in the exponent. So, currently we have decline rate equal to 100 times d per day. By multiplying the value of d with total day per year, we got the annual decline rate of a well. Annual decline rate represents the decrease of injection mass flow rate each year. Therefore, we can estimate the well sustainability in the future. At the end of this video, let's take a quick recap from the discussion earlier. First, decline curve analysis in geothermal is the same technique that is used in oil and gas industries. Second, normalization is a must before we construct the decline model. And last but not least, exponential equation help the engineer in injection well management.